Synthetic oil is a lubricant consisting of chemical compounds that are artificially made. Synthetic lubricants can be manufactured using chemically modified petroleum components rather than whole crude oil, but can also be synthesized from other raw materials. Synthetic oil is used as a substitute for lubricant refined from petroleum when operating in extremes of temperature, because, in general, it provides superior mechanical and chemical properties to those found in traditional mineral oils. Aircraft jet engines, for example, require the use of synthetic oils, whereas aircraft piston engines do not. Synthetic lubricants are also used in metal stamping to provide environmental and other benefits when compared to conventional petroleum and animal fat-based products. These products are also referred to as non-oil, or oil-free. Types: synthetic oil, synthetic base stock lubricant oils, as described above, are man-made and tailored to have a controlled molecular structure with predictable properties. They are composed of organic and inorganic base stock oils combined with polymer packages to produce synthesized oil compounds. POW, API Group 4 polyolefins, 100% synthetic chemical compound. Specific type of olefin that is used as a base stock in some synthetic lubricants. Polyalpha olefin is a polymer made by polymerizing an alpha olefin. An alpha olefin is an alkane where the carbon-carbon double bond starts at the I+ or minus carbon atom, that is the double bond is between the number 1 and number 2 carbons in the molecule. Ester, API Group V. Esters are 100% synthetic chemical compounds consisting of a carbonyl adjacent to an ether linkage. They are derived by reacting an oxoacid with a hydroxyl compound such as an alcohol or phenol. Esters are usually derived from an inorganic acid or organic acid in which at least one OH group is replaced by an O-alkyl group, and most commonly from carboxylic acids and alcohols. That is, esters are formed by condensing an acid with an alcohol. Many chemically different esters due to their usually excellent lubricity are used for various reasons as either additives, or base stocks for lubricants. Semi-synthetic oil. Semi-synthetic oils are blends of mineral oil with no more than 30% synthetic oil designed to have many of the benefits of synthetic oil without matching the cost of pure synthetic oil. Motul introduced the first semi-synthetic motor oil in 1966. Lubricants that have synthetic base stocks even lower than 30% but with high-performance additive packs consisting of esters can also be considered synthetic lubricants. In general, ratio of the synthetic base stock is used to define commodity codes among the customs declarations of tax purposes. Other base stocks help semi-synthetic lubricants. API Group 2 and API Group 3 type base stocks help to formulate more economic type semi-synthetic lubricants. API Group I, 2, 2+-, and 3 type mineral base oil stocks are widely used in combination with additive packages, performance packages, and ester and/or API Group 4 polyalpha olefins in order to formulate semi-synthetic based lubricants. API Group 3 base oils are sometimes considered fully synthetic, but they are still classified as highest top-level mineral base stocks. A synthetic or synthesized material is one that is produced by combining or building individual units into a unified entry. Synthetic base stocks as described above are man-made and tailored to have a controlled molecular structure with predictable properties, unlike mineral base oils, which are complex mixtures of naturally occurring hydrocarbons and paraffins. Performance advantages. The technical advantages of synthetic motor oils include better low and high temperature viscosity performance at service temperature extremes, better viscosity index, better chemical and shear stability, decreased evaporative loss, resistance to oxidation, thermal breakdown, and oil sludge problems, possibility to extended drain intervals, with the environmental benefit of less used oil waste generated, improved fuel economy in certain engine configurations, better lubrication during extreme cold weather starts, possibly a longer engine life, superior protection against ash, and other deposit formation in engine hotspots for less oil burn-off and reduced chances of damaging oil passageway clogging. Increased horsepower and torque due to a less initial drag on engine, improved fuel economy, from 1.8% to up to 5% has been documented in fleet tests. Disadvantages. The disadvantages of synthetic motor oils include, substantially more expensive than mineral oils. Potential decomposition problems in certain chemical environments, see also. 3000-mile myth, Petro 1, Total SA. Amsoil, Amol, Castrol, ENOC, Fiscara Eurotrop Process, Mobil 1, Motor, Pennzoil, Redline Oil, Royal Purple, Schaefer Oil, Silver State, Synthetic Fuel. References